everyone to all. My name is P. Kodanda Ramaiah, Assistant Professor of Mathematics. So today we are going to discussing about linear differential equation of second and higher order. So the differential equation of second and higher order is most important for the beta courses. Linear differential equation with constant coefficients. A general linear differential equation of nth order with constant coefficient is given by k naught d power ny by dx power n plus k1 d power n minus 1 into y by dx power n minus 1 plus and so on plus k suffix n minus 1 into dy by dx plus k suffix n into y equals to f of x, where all k terms are constant and f of x is a function of x alone or constant. So the general linear differential equation can be operator form is k naught d power n plus k1 d power n minus 1 plus and so on plus k suffix n minus 1 d plus kn into y equals to f of x. So or f of d into y can be written as capital F of x. You can write the entire general form can be simply written as f of d into y equals to f of x, where d power n equals to nth derivative term, d power n minus 1 equals to d power n minus 1th derivative term, and d equals to d by dx are called operator differential operators. So how to solve second order linear differential equations with constant coefficients? So the complete solution of equation f of d into y equals to f of x. The general solution of the second and higher order of linear differential equation is y equals to cf plus pi. So where cf equals to complementary function and pi equals to particular integration. In case f of x equals to 0, that means f of x means RHS term equals to 0, then the solution of equation f of d into y equals to 0 is given by y equals to complementary function only. So here complementary function is depending upon the LHS side of the given differential equation. Particular integration is depending upon the RHS side of the given differential equation. Here, RHS term, so f of d into y equals to 0. So RHS term equals to 0. So that's why particular integration is 0. So y equals to complementary function is general solution of the second and higher order of linear differential equation. The rules for finding complementary function. So definitely we can find out the complementary function. We are following these rules. So consider the equation f of d into y equals to f of x. So that equation can be written as k naught d power n plus k1 d power n minus 1 plus and so on plus k suffix n minus 1 into d plus k suffix n into y equals to f of x. So now we can find out roots of the given differential equation. Definitely given equation can be converted into auxiliary equation is given by f of m equals to 0. So that means d term can be written as in terms of n. So that means k naught m power n plus k1 m power n minus 1 plus and so on k suffix n minus 1 into m plus k suffix n equals to 0. So here we can write the complementary function. Definitely we can find out the roots of the given differential equation. How to find out the roots of the given differential equation? The complementary function is depending upon the LHS side of the given problem. So this is LHS part of the given general linear differential equation. So by using this LHS part, find the roots. How to find out the roots for the linear differential equation? We can find out the roots of linear differential equations are two types. That is, first one is a factorization method, and the second one is a minus b plus or minus root of b square minus 4ac by 2a. We can follow these two procedures, find the roots of the given linear differential equation. That means second order linear differential equation. In case third order linear differential equation, how to find out roots of that equation? So that given equation is cubic equation, means definitely we can find out the three roots. So on that time, we can find out one approximate root of that given differential equation by using trial and error method. We can find out one root by using finding root, by using synthetic division, for that the cubic equation will be reduced to second order differential equation. After converting the second order differential equation, like now we can find out as usual procedure of a second order linear differential equation. So in case if two roots are real and distinct, say m1 comma m2 comma and so on m suffix n, then complementary function equals to c1 e power m1x plus c2 e power m2x plus and so on plus cn e power mn x. So here two roots are different, distinct here. In case on that time we can write only for up to two terms. In the same, three roots are different and distinct, so we can write up to third term of this general complementary function. And next, if two roots are equal, that is m1 equals to m2 equals to and so on m suffix n. So on that time, complementary function equals to c1 plus c2x plus c2 c3 x square plus and so on c suffix k x power k minus 1 into e power m1x plus c1 cn e cn e power mn x. So if only we can take two roots, we can write up to two terms, that is c1 plus c2x. In case three roots are equal, so we can write up to three terms, c1 plus c2x plus c3x square. And next rule is, if auxiliary equation has a pair of imaginary roots, that is m1 equals to alpha plus or minus I beta, complementary function is e power alpha x into c1 cos beta x plus c2 sin beta x. And fourth rule is, if two pairs of imaginary roots are equal, that is m1 equals to m2, that equals to alpha plus or minus I beta. So on that time, we can write complementary function is e power alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x plus and so on plus c suffix n into e power mn x. So these are the must and should follow the rules of the complementary function. So we can take one of the example of that problem. D square y by dx square minus 8 dy by dx plus 15y equals to 0. So here the RHS term equals to 0. So that's why the particular integration is 0. So the general solution of that equation is only for y equals to complementary function. So complementary function is clearly, I have mentioned in the previous scenario, LHS term of the based on the complementary function. So this equation can be operator form is d square minus 8d plus 15y equals to 0. The auxiliary equation is m square minus 8m plus 15 equals to 0. So this is second order linear differential equation. So by using this equation, find the roots. You can follow the either factorization method or minus b plus or minus root of b square minus 4ac by 2a. So 15 can be written as 5 3s are 15. So m minus 3 into m minus 5. So m equals to 3 comma 5. So the complementary function c1 e power 3x plus c2 e power 5x. So f of x equals to 0 means RHS term equals to 0. So particular integration 0. The general solution y equals to complementary function only. Therefore, y equals to c1 e power m1x plus c2 e power 5x. So this is the final general solution of that given differential equation. So one more example of that one. Solve the differential equation d cube y by dx cube minus 6 into d square y by dx square plus 11 into dy by dx minus 6y equals to 0. So this differential equation is a cubic differential equation. Definitely we can find out the three roots of this equation. So that equation can be operator form is d cube minus 6d square plus 11d minus 6 into y equals to 0. So the auxiliary equation of that equation is m cube minus 6m square plus 11m minus 6 equals to 0 by using trial and error method. So put m equals to 2 for this equation, definitely that value will be 0. So by using m equals to 2, by using synthetic division or a substitution method, any one of that one. So m square, m replacing m minus 2 minus 4m into m minus 2 plus 3 into m minus 2 equals to 0. So that one can be simplify m square minus 4m plus 3 into m minus 2 equals to 0. So that one can be written as m minus 3 into m minus 1 into m minus 2 equals to 0. Totally, roots are m equals to 1 comma 2 comma 3. Here, three distinct roots. So that's why complementary function C1 e power 1x plus C2 e power 2x plus C3 e power 3x. Here also RHS term equals to 0. So that's why particular integration also 0. So only for complementary function is a general solution of that one. So that's why the solution is given by y equals to complementary function. Therefore, the general solution is y equals to C1 e power x plus C2 e power 2x plus C3 e power 3x. So this is only for RHS term equals to 0. So next class I have going to discussing with the RHS term is some exponential function or trigonometric function or polynomial function or e power ax into p of x function. So thank you.